So, thank you very much for gathering and attending to this late time. And this is the third day, and I hope you enjoyed the 3 day seminars. It was organized by Ijun and his friends. And the purpose, the main purpose of organizing this seminar was that, firstly, we thought we should uh, give you the facts and truth. And secondly, we should provide you our professional judgment about the earthquake and the tsunami and what happened, and also what we should do for the future. Could you put down the light in the front side? So some of you mentioned one of the important points is about fact. I'd like to show you one interesting fact: the rate of successful evacuation. This is defined as follows: the number of successfully evacuated people over these people and dead or lost. So you can calculate how many % of the people could successfully evacuated among those who should evacuate. I calculated the numbers for 36 towns in 3 prefectures. I mean, Iwate, Miyagi, and Fukushima prefectures. And of course, you know, as Professor Ando mentioned, Otsuchi is a quite seriously damaged area, so the lowest number was recorded in Otsuchi. And the second lowest, this city, third lowest, etc. So I'd like to ask you, how much will this late in Otsuchi, etc. Right. So of course you are specialist, you know already. So I'd like to ask some of the foreign student or student to answer this number. Could you please, this one? 60, 50, half.
Yes.
Okay, thank you very much. And so maybe Jiaoshi, Minami Soma, second one.
30.
30. How do you evaluate this number approximately? Okay. So I think most of the people like you think that this number is very low, because we have been informed that many people have died. And there are so many people who couldn't evacuate it. And there should be so many people who evacuated but died by tsunami, because the evacuated place, the shelters are not well protected. I will show you the actual number. The successful evacuation rate in the lowest one in Otsuchi is 75%. And these 80, 81, etc. And most of these towns in the coastal region records 87% to 99%. Of course, I don't say this number is high enough. That means 1/4 of the people were died. So it's a sad number. There are so many things we should improve. But don't you think our people in Tohoku area were quite resilient and quite adaptable and quite strong people who know what would happen, and who most of them evacuated in advance. So we can find the tips for the better improvement for the future here. So this is the fact. So I hope you will find many facts you found many facts through these seminars, 3-day seminars. So as a whole, you observed many seawalls or bay mouths, breakwaters, or shelters or nuclear power stations were broken. Or at least they worked as far as tsunami is not greater than the designated level, of course. But however, if once tsunami gets far beyond the designated level, there are so many problems. So key point is designated level or designated subject of tsunami or earthquake. So this is my key point, which I'd like to deliver to you today. So as a whole, we are now thinking that we should introduce the concept of two-step protection from disasters. First step, prevention. This is for the frequent but less serious hazards like low-level tsunami or not strong, very strong earthquake, etc. But what we found through this earthquake and tsunami was that we have to take care about the second step, mitigation. There are the several hazards which is very serious, but it happens less frequently. But we must not neglect the existence of such kind of events. We have to take care about this. But it's not reasonable to protect or prevent such kind of things because this is very serious and very large hazards. So we have to deal with this kind of hazards in the sense of mitigation in order so as to reduce the whole damages. At least we should protect our people's life, etc. But this is not the very new concept in our overall the protection from disasters. We had many experience up to now. For example, better design or anti-quake design of the structure, like a concrete ramen structure, etc., is a quite good example with which we improved the design procedure or concept or methodology, as well as we developed the reinforcement measures after we experienced very serious damages in Hanshin earthquake in 1995. Through these 15 years, more than 15 years, we improved such kind of measures. Therefore, in this earthquake, we observed a few not very serious damages in the Tohoku Shinkansen, etc. But we could repair this very quickly. And there was no serious damages on the trains over there because the structure itself did not fall away. There are so many examples like this two-step approach. This is the derailed Shinkansen train occurred in Chuet's earthquake in 2004. This is the first experience of Japan to have the train Shinkansen high-speed run, fast-running Shinkansen train to be derailed. And up to that moment, we put our maximum effort to prevent the derailment. But we didn't think anymore what we should do after, even after the derailment happens. But if once we observed actual derailment, we started to prepare for the derailment. Of course, it's better to prevent the derailment, but in a very serious movement or motion of the earthquake, it is almost impossible. So in this case, the Chuet earthquake, this train set or cars leaning toward the another track, and if once there was the opposite train coming toward this way, there must have been a very serious number of deaths. But quite fortunately, there was no train there, so no one lost and no one injured, quite successfully, quite fortunately. So therefore, the railway companies and the Ministry of the Transportation started to put in or develop technical measures to prevent such kind of the spatial movement even after the derailment. It's not the prevention of derailment, but the kind of a mitigation of the damage of the possible derailment. So it is also the example of such kind of two-step protection. So little by little, we have been expanding this idea toward this field, that field, and then we are now going to expand this idea to the tsunami disasters. This is new step. So in this sense, I can say the technical system or engineering system have been evolved little by little. Of course, it is not very fast, but little by little, we have been improving, and we have been evolving the technical system. And of course, disasters or accidents, these are the serious and quite sad experiences, but of course, this is our responsibility, or engineers' responsibility, to utilize this kind of sad experience in order that we can utilize the experience to the maximum extent to the better future of the human beings. So, of course, we observed many phenomena of the vulnerability in cities. In a sense, vulnerability can be the weakness in the dynamic processes. And of course, in the opposite concept to of the vulnerability can be toughness in cities. So we have to make our cities much more tough by improving various virtues like adaptability or resilience or stability or cohesiveness, robustness, tolerance, flexibility, diversity, etc. So I'd like to come back to the idea of evaluation of two-step protection. So maybe we can say the idea of prevention is a kind of a concept to be prepared against designated hazards. So we set up such kind of hazard, and we will prepare for this. And if we don't take care about mitigation, that means we don't take care about the world beyond this designated level. But consideration about mitigation means that we have to take care about the over-designated hazards. So if we neglect this latter part, maybe we are thinking in such a way that we have boundary in our brain, okay? There's a boundary. We think just this world. We don't think about this world. So this is a kind of a boundary in thinking. So we have to eliminate such kind of boundary of thinking from our engineering sense of view. So if we come back to the very typical and standard way of thinking in the modern scientific world, we think like this. We set up firstly the boundary, and this is our world. And we set up the definition of the problem. And we are influenced by the elementalism, segregation, okay? This is the world of electricity, and this is the world of civil engineering, etc. And we concentrate on this limited world and to find the optimum solution. This is the basic way of scientific thinking. But of course, this is very efficient as far as there's no problem. But of course, it is obvious that this boundary will face some limitation in the future. And this elementalism will face sometimes in the future. So therefore, it is very important thing how we can overcome this limitation in thinking. That maybe there will be two senses. In a system or procedure, maybe integrated thinking, integrated way of consideration or analysis, etc., or holism is important concept, other system. But for the individual engineers or planners, I think curiosity or imagination toward the world beyond your designated world is a key virtue to overcome your boundary in the thinking in your brain. And boundaryless communication. So this is one of the reasons why I asked several students to organize this international seminar, so that you can exchange your idea or your question and your anxiety or your idea also for the future. So I hope you will keep your mind curiosity or imagination and boundaryless communication.